Okay, just to clear things up from yesterday, since we're all studying computer science and we get into technology, we don't want to avoid complex topics, but we still have to consider stepping up to them and just taking them a little bit at a time and just opening up your mind to moving forward to other classes in third year. I've taught operating systems a number of times, and just keep in mind that there are software projects that are huge. Operating systems themselves contain 70 million lines of code and upwards, and they have tens of thousands of engineers over decades having worked on them. They're absolutely massive. When we're working with generics, we open up a can of worms. So I would like to have had a simpler version of what was in the textbook, but then we get into issues where creating an instance of a generic, you get all these other examples online if you go to Stack Overflow. So just briefly, I'll bring one over. It's okay to go to references where people are discussing how to get a solution to something they're working on in code, but we want to be aware of how to scrutinize the examples. So this one's discussing generic array cast exception. Um, and they give lots of different kind of examples here, and people are trying to describe the best they can for everything. The solutions that people were giving for creating an instance of generics had quite a lot. And it gets into problems where a couple teams I was showing how to create instances using reflection. That's definitely beyond the scope of this class, but I do want to address it quickly as I can. Reflection has been removed from future versions of Oracle's Java. So anytime you see an example of people using it, you just want to be aware that you should be moving on to some other kind of solution. Now, part of the reason they want to upvote those kind of solutions is because they're likely much smaller. They've only got a few lines of code to do what they want versus the other solutions where people are listing like 50 lines of code. The larger solutions there are going through all the checks that you would want, which seems kind of ridiculous. If the only thing we really want to do is just say new and then create whatever it is we're wanting to work with, we look at those other solutions and see how big they are and think like that's kind of ridiculous. But if you're writing a huge project with lots of code and you're wanting to do everything with security and checking all the different issues to make sure everything's okay, you'd likely want those more complex solutions. But for learning purposes, we don't want to get into that. So, after all that preamble, I think I've come to something that's reasonable. It is slightly different from what the textbook has, though. It is a little bit simpler. I'm not using the comparable or the comparator that they've got that's internal to priority queue that they have for their code in the text. So for our version of code, instead I'm having the type guarantee that it's got the compare to method. So I was talking about this with teams inside class yesterday, where we've got our wrapper, and I wanted the compare to method to be inside the wrapper class. I've also taken care of the issue where I was discussing with a few teams trying to set up a minimum default, which we could do like I was describing. The wrapper just contains the minimum integer value that you could have, and it's just setting up a static instance that you can refer to. You only need the one to make a reference to it to do comparisons against what would be the minimum or considered the minimum. Okay, so since we've got this guarantee, anywhere we're working with t, we should be able to then make a call to compare to if we want. So we've got a compare method if we want to use it in our code. We've got that method set up internally to minheap, and we could do the first one called against compare to for the second. If we want to write our code to look more like we had done with sorting previously to this. Really, there's not much difference. It's just that you're making the call to compare to based off the first object compared against the second. But if you're more comfortable with how we did compare previously, you can make a call to the compare. And then we've got the first parameter against the second parameter. Okay, the other issue is setting up default capacity. I've got a constant. With the way that I've got the code set up for displaying your trees inside a panel, you can really only get away with having so many before it starts to get ridiculous. So I've limited it to about 32 nodes. Now you can play around with this yourself. If you want to do some editing, you could try doing different things. Maybe try drawing your tree in a slightly different way if you wanted more nodes. I think that would be fun for you to practice if you wanted to try messing around with that. Down here we've got constructors, which is really where the main issues with differences from the textbook arise. So you're going to get warnings if you try to do what the textbook is doing, and then you're going to get runtime errors likely if you try to do the way the code is in the textbook. So to actually get around this in a reasonable way without having to do any suppression of warnings, which you really want to avoid if you can manage. Really the only reason you would want to be suppressing any warnings with annotations, let's see if we do at, where do I have it? Suppress warning, and then I think they do unchecked. That could be one of them. You don't want to use that as a way of fixing any issues, because otherwise you're just using it to do testing and debugging, so that way you can focus on certain kinds of output messages from the compiler. Okay, this we've got minheap where we're passing in 3 things, so we can actually get away with creating instances for our generic types. I'm getting away with this by having the client code pass in an instance of our type first. That way we can use it. And then the in function, I'll explain what this is doing further down when we go to create arrays that we would like of our type, and then how large would we like our array to be. Okay, I really don't want to have to depend on an array list, but if I'm going to pick a collection to work with where I can change the size of things, this is going to be the one I want. I think Team 1 actually had used something similar to this. I'd be interested to have more discussions about this in class with the way you had your code working. The example I'm trying to present here is I would like to get the most generic form towards what the textbook has that I can, without as much complex code as possible. Okay, with our type inside the array list, we've got elements of what we're interested in sorting. And then once I've got my array list of this type, I could add. But in order to add, I have to be able to work with instances of the type. So again, you're going to have to jump through hoops. And I'm getting around that by passing in an instance that I can add to my collection. This way I can get an array list of the size that I'm interested in, so that way I could create an array of that size. If I call toArray though, if I do it in different ways, you're likely going to get these kind of runtime errors. And in order to get around that properly, we actually have the int function class. This I'm going to grab from java.util function, int function. This will allow me to call some kind of function I'm interested in. I'm interested in the constructor. So this is the type that I'm passing in. I would like to create an array of my generic type. What is a parameter I would like to pass to the constructor? I'm just passing in a default value of 0. Now I'm not completely sure whether that's what's going on, but that's my best guess, because when we go to apply that constructor, I would likely imagine that we want to pass these parameters to. When I was looking at the documentation, that's about roughly my best understanding of it. Now if I bring up the client code where I've got plot.java and I scroll down to where I'm passing in the constructor, what does that look like? You prefix with the type, and then what's the actual constructor? I'm getting away with saying the scope for that type. So double colons, this is controlling the scope that I'm working with. And then the constructor I'd like to work with, so new. I want to create a new one of these. And then the size I would like just to work with, maybe 32 for default size. When we come back, we would then have our temporary array list. I don't think I need the parentheses before, because I was playing around with casting things, and that was causing the errors, and we want to avoid those, and using any other weird workarounds. Okay, we're still good. And just to make sure people are convinced that we've got things working, we can take a look at an example. Once you've got the array, then you're just setting the parameters for other things, like the actual number of elements that are currently in your min heap to be 0, and the height would be 0. And then we could start adding things to our heap. And we've got roughly about 32 elements to work with. So the capacity is larger, of course, than the number of elements that we currently start with. The other constructor that we would want is to pass in, so similar to the way the textbook code has it set up, we would want to work with some other generic kind of collection. And we might want to convert this to a min heap. So the way we could do this is to pass in collection, and then the elements inside that collection should match with the type we're interested in. And then we see the same kind of code. We've got int function passed in with cons. We're going to do the same kind of steps. Now, one of the issues I ran across here is that there's a certain number of elements that are already in the collection. So I was playing around with reducing the number in order to then turn around and add more elements afterwards. We could edit this to look more like the first constructor, where you could change the number of elements you're interested in, potentially, and we could work with array list. We could build up some other number to work with, and then copy over the elements from our array into the new size. I think that would be good practice, actually, if you edit the code to do that. And then we're in the same situation as before, except we call build heap at the end to get it into the proper arrangement of elements so that we've got the heap properties. Okay, all the code after this is just making sure that you're working with the generic type then. So small issues that are coming up everywhere else, it's really just doing the compare to call, or if you prefer, you could change these kind of expressions to make use of compare. like you were more familiar with in our previous sorting. So I'm just making use of compare to everywhere, and we're guaranteed to have this because of the contract with the interface that we've got with our wrapper. We're implementing comparable. What do we want to compare instances of wrapper against? Other wrappers. Okay. And that should roughly take care of most of the issues. Not as nice as I thought it was going to be, unfortunately. So maybe a brief comment about some of the updates to Java. They took away reflection from Java version 16. And then there's still ways to get around that in Java 16. And then they took away those alternatives from Java 17 even. Part of the reason they did that is because they don't want people coupling their code together with other modules that are internal to the JDK, the Java Development Toolkit. The separation ensures that you have more security, that when they change things internally in the library themselves, that other people are not depending on those changes that would then break code. So I'm just trying to summarize that issue the best that I can, but that's actually quite a big topic. If you are really curious about things like that, and you want to start looking ahead to these kind of issues that you might get into in things like, say, operating systems, you have to start worrying about versions of code and how your libraries change. So when you're making use of other people's code. And this is a blog article written by people that are developing with Oracle for, instead of OpenJDK, they're working on Oracle versions of Java. You do want to start opening your mind to those kind of issues when you start getting into upper level courses and then you move on to working in industry. There's no way around it. You have to pay attention to them because there's issues of security. You want your code to be secure, and you also have to update your code with newer versions of everything, which is really like a huge topic. And you can only just pick away at it. You can't learn everything all at once. So it's good to be open to these ideas. You're not expected on any kind of test. I'm not going to be asking any kind of ridiculous questions about things like reflection. And even for the midterm, if we're looking at generics, I might have maybe one question involving generics themselves, but I'm not going to expect anybody to sit down and write code on paper using generics. Okay, so this is a good time to begin to be aware of those kind of things. And I'm happy we go through the pain of it and data structures and algorithms just to get started looking into them. We really do want to be aware of generics and start learning how to use them. But as we move on, we'll probably only bring it up for abstract data types that are simpler, like MinHeap. Again, I realize that when we're looking at projects where we've got, a couple files like this, and I'm giving a little bit more code, it looks like a lot. It's really not a lot of code. So we're building up your stamina for also handling larger issues and then larger amounts of code. Okay, thank you for your patience. We're going to keep marching forward, and I'll try to make things as organized as I can as we move forward further.